So this is the problem that we're looking at, right? So we're going to look at two problems in translation. So you have, and this is problem 2 from your problem set, which I will post either today or on Thursday, because we're not going to finish the 2 problems today. So you have a 20-kilogram cabinet that is mounted on casters that allow it to move freely. Basically, the coefficient of kinetic friction is equal to 0 on the floor. And you're told that 100 Newton force is applied as shown. And you're asked to find the acceleration of the cabinet. And you're also asked to find the range of values for this height h at which this force acts, for which the cabinet does not tip. All right. First part is pretty simple. F equals ma, you get the answer pretty straightforward. But going back to our process, first thing, coordinate system. What's the next thing that we do?
FBD.
FBD. FBD. There, right? So on the FBD, I have my weight that acts, right? Then I will have a reaction at one caster. So let's define these points. I'll call this point A. I'll call that point B. So RA and RB, right? And these act such that this distance is 0.3, and that distance is 0.3 meters, right? Because we know that the mass is going to act at the center, right? And then you were told that there's a horizontal force of 100 newtons that acts at a height h. All right. So for the first part of the problem, considering the fact, let's consider that moving in the positive x direction is positive, can say that sum of forces in the x direction. Oh, wait, I'm skipping a step. You guys, no one told me. What did I forget to do?
Kinetic diagram.
Kinetic diagram. All right, KD. And this is in problem in pure translation, right? So it's only going to translate in the x direction. So let's say that that's MA like that, right? And that is from the problem statement at a height of 0.9. All right, so part A, consider the positive direction to be in the positive x-axis. Say that F of forces in the x direction is equal to MA, right? And what are the forces in the x direction?
Just the 100 newtons? Just
the 100 newtons. So 100 newtons, and it's in the positive x direction, which you define to be positive, so make that positive. And that's just going to equal MA. So basically, acceleration is going to equal 100 newtons divided by the mass, which is 20 kilograms. That's 5 meters per second squared. But guys, remember, when we're talking about dynamics and people ask you the acceleration, just the magnitude is not good enough, right? So having defined our coordinate system like that, you can say that the vector A is just 5 in the I hat direction. All right, so for part B of the problem, what we're going to do is, what scenarios do we have for tipping? What are the possible ways that tipping can happen?
Pushing too high on the cabinet?
That's right, but we have to find out the range of values about which it does not happen, right? So what about what points can tipping happen?
It would tip when either RA or RB are 0.
Exactly. So that's exactly how we solve this problem. So what we're going to do is we're going to assume tipping about the point B, right? And then when that happens, RA is equal to 0. We'll get a value for H. We'll do the same thing for B. We'll get another value for H. And as long as H is in between those two values, this guy's not going to tip. Is that clear, guys? Does that approach make sense? So tipping to impend about the point B, what happens is that the reaction force RA is going to equal 0, right? Because it's going to start tipping. And what we'll do is let's consider clockwise moments to be positive, right? Just for the sake of making things easy, right? So now, when you're doing this for moment about tipping about B, what's the easiest point to take the moments about?
Would be the mass center?
No.
Would it be
If you
A?
take it about, no, because if you take it about A or if you take it about the mass center, you're going to have to find out what RB is, which then you'll need to go back and do the static equilibrium, not the static equilibrium, but sum of forces in the y direction, right? A direct way is to just take the moments about the point B, right? Then you don't need to worry about what RB is, right? So taking the moments about the point B, right? So saying that clockwise is positive, I'll have a moment due to the 100 Newton force, which will be 100, and the perpendicular distance to that is equal to h, right? And then I'll have a moment due to mg, which is going to be negative, right? Because it's going to be counterclockwise. So minus mg, and the perpendicular distance to mg is 0.3 from the point B. So this is just equal to that, right? And this is equal to MA times 0.9, right? The perpendicular distance. And that's positive as well because that's clockwise. So MA times 0.9. Plus IG alpha, right? But what can I say about this IG alpha? When tipping starts?
0.
0, right? Because this problem is in pure translation and you don't want tipping to happen. And when tipping just starts, the angular acceleration is anyways going to be equal to 0. So this term is just equal to 0. Right, so here, you know everything except h, right? You found out what everything is. So if you solve this, you get that h is equal to 1.489 meters. Similarly, we do tipping to impend about A, then you say that the reaction force at B is equal to 0, right? Do the same thing, say clockwise positive. Now you take the moments about A because then you don't need to worry about RA, right? So similarly, about A, you'll have 100 newtons times H in the positive, in the clockwise direction, so positive, so 100 H. Now mg will cause a clockwise moment, so that's positive. So you'll get plus mg. The perpendicular distance remains the same. That's 0.3 meters. Right? And again, that's equal to ma times 0.9, right? About that point A2. It's going to be a clockwise moment, so that's positive as well. That's just equal to ma times 0.9, like that. Again, here you know everything. So MGMA, right? So H is equal to, you solve this expression, you get H is equal to 0.311 meters. Right, and from there, you get the bound, and you can say that the cabinet will not tip if 0.311 meters, if H is between 0.311 meters and 1.489 meters. Sorry, we went 3 minutes over, guys. That's par for the course. All right, questions, guys? If not, I'll see you guys on Thursday. All right, thanks.
See you Thursday.
Thank you.
Thank you.
Mr. Stroud,
Yes.
so did you see my email?
Yeah, I saw it.
Does that work? What's the problem?
It's I'm pretty sure it's problem 210.
And chapter 5 or 6?
Pretty sure it's chapter.
Well, not 5. Damn it! It should be. It's in the teens, right?
Well, yeah.
13.
Trying to find it. I just have all this stuff on my.
No worries. Why don't you find out and just shoot me an email? How about that?
Yeah, I'll
I'll
send it to you.
All right, sounds good.